Bradley.
Hello, how are you?
At any rate, welcome back to Cognition Futures.
Yeah, good to be back.
It's been the longest hiatus in a long time for that, but appreciate sticking with it through that. I guess I have a few updates, I guess. Amanda said some of my stuff. I don't know if you want to say that here or not, it doesn't matter. But my general updates are, I think I'm going to be going to England in a few weeks, mostly for plot twisters. There's an event at a university there, a conference that we've been invited to, and it's kind of interesting because I was originally not even going to go at all, and now I've been one of the core people that's going because some other folks may not be able to go. So it's funny how that goes, but so there may be a chance to do. I don't know if we'll be able to. If there's any context that we have, kind of in London or Oxford, let's reach out to them and stir the pot. I know we kind of haven't talked to Charlotte in a while. She is, I think, in London and so on. But that would be basically in and around May 1st. May 1st is the event. Still waiting to hear back from Dizzy, which would be another major European adventure for me. We'll see. But I will be at, as it stands, I will be going to the event on May 1st.
Yeah.
I also I've been looking through the Google Summer of Code thing, so thank you for that, Bradley, and I'll hopefully study stuff tonight.
Sorry, could you say more about what you're looking for in Oxford?
Oh, hi. Yeah. I'm going to be there basically. Well, to quickly recap what I said earlier, I'll be there for plot twisters predominantly at the Inclusive Gaming Conference, which is held in Oxford at the Oxford Internet Institute primarily. But I am also, if there's contacts that we have in the lab or even through Neurotech or whatever, that would be good to reach out to, let me know, because I think I'll have a little extra time. I should be there maybe. This is not set in stone, but I might have about a week in the area. There are some things for other groups I'm definitely looking at. There's been some new really interesting research programs that happen that are super relevant to some other things that I'm doing that I'm hoping to kind of check out too. But I will have time in London, and I will have some time in Oxford specifically in Oxford. So if there's anyone that you would like me to reach out to or connect with or follow up with or what otherwise network or talk to, let me know, because I'll have kind of a surprise opportunity to go there. I wasn't expecting to go, but now it'd probably be pretty good if I go to help out plot twisters and other things too. So we'll see.
Is there I mean, when you say like nerd, obviously I got tons of Neurotech contacts. If that's what you're interested in, and postdoc just spoke at Neurotech X Hong Kong because they just had an inaugural meeting, for instance. But I'm not sure if that's if that's kind of the research things, or would it be like maybe autism studies that you've talked about before, or help me narrow.
Okay, cool. I think the best thing for me to do is I'll get at you in Slack and converse there about a bunch of stuff, because there's a number of things like on different projects that would be cool that you may have some things to point to. So I will definitely follow up with you about that, and I appreciate that. That would be good. Oh wow, I have this little book next to me called The Home Computer Revolution, and it's like it's $2, and it's from like I think the 70s or 60s or something. Anyway, outside of that, other updates for me, the next spring term 2024 is underway. Um, I think maybe the most relevant things for some of this group is I'm taking a really interesting data ethics and fairness course, which kind of related to set stuff, but also um, there's an interesting all the things that we've been talking about in terms of philosophy and science and how things are done are really relevant. And I actually feel I feel uh, very fortunate that I've been in this group and the cybernetics group and just the lab in general because um, the way we've been able to talk about stuff is way more. I don't know. It seems much more alive and relevant to a lot of things than I realized, especially for people in the space of of data ethics, because you're at the we have like the measurement problem, we have the ethics stuff, even outside of like the ethics stuff and societal stuff, which is important. All the way we've been able to talk and normalize talking about understanding measurements, what does it mean, sort of what's even like all the phenomenological things you looked at and the measuring and data and assumptions and what to do with that data is actually really relevant. And um, I feel surprisingly like fortunate about that. So thanks to everybody for like unintentionally giving me a very good education in a lot of those things over the last few years. Um, Show Pro has been a little bit on hold because of just some other stuff, and then Plot Twitch has kind of just burst with a bunch of things that are happening here recently. The DSM project is still going. Jen is actually writing a kind of a critique slash literature review base potential literature review on I think it's a documentary about mental health that she was fascinated with and also like a bit put off by. So I'm like, yeah, like go like she just wanted to write about it. It's like, yeah, just write, just keep building stuff up and going forward with that. So in the future I would like to really I don't know if I'm just gonna incorporate it under the banner of Cognition Futures or not. I don't particularly care to I don't care about what banner it is or under, but like I look forward to actually talking about some of the things that have slowly emerged therein. Um, but that's still happening. It's just been a kind of disorienting week because I'm back from my sickness and now here, and then I have this huge event tomorrow also on well, huge in content, but I'll see if I can just pull this up. It's not really going to be that informative, but it's this event at the Media Lab and some big whatever future of AI stuff, all sorts of business and whatever. But I know I don't know if I can zoom in here. This is I can't zoom in. Okay, let's try this. Oh, this is not going to work. Do anything. I narrowly. On a related note, I narrowly missed out on actually going to Michael Levin's lab for a talk, and I'm so disappointed. Um, one of my good friends was invited by someone at another local talk. I think it was Joseph Bach, who was giving a little talk and got an invitation to do something with Levin at Levin Lab. And I almost, if I was there not busy with this stuff, I probably could have gotten to go, and that would have been awesome. So on the list of things that we'll try to do in the future. But today, at this event tomorrow, I think we mentioned a long time ago, Daniela Russ, she'll be at one of the, what is she doing again? Robotics.
Yeah.
Okay. I may be able to see her tomorrow on a panel with, she's at like a liquid AI panel with Alexander Amini, Ramin Hassani, Daniela Rus, and Joseph Bach. They're on one of the panels for this event, and there's a bunch of people. I can't. Their website's a little difficult, but there's going to be a bunch of. There's this big whatever event tomorrow. Okay, I guess it's up here. So Wolfram's going to be there, and I can't even move up and down on this. But if there's anyone here, I'll put this in the chat. Make it much easier to navigate. If there's anyone here that would be good to like follow up and or try to connect with or look at what they're doing or whatever, let me know, because I'll have some.
Please post that in the Slack, because I'm doing school pickups. But that's super interesting, and like 11 just had applied category theory person talk, and I forward that to my category theory friend, and it's some really interesting intersections between that and the Strathclyde. I'm forgetting the guy's name right now, but anyway, there's some really interesting stuff in combination cybernetics, free energy principle, compositionality, and just all under kind of category theory that he's following up on. That's really interesting. I was just it was cool to see 11 doing that too, or at least talking about it.
I've been trying to get some of his videos because he posts a lot of good stuff on his YouTube channel now. But yeah, let's see. I don't see Russ here. There's Russ. There's a few names that I know we know talked about a bit, but I'm trying to find specific people. There's like a whole bunch of people.
What is the theme? I mean, what is it supposed to be? Like, it's business with AI.
It's like hashtag is like forging at MIT, forging the future of business with AI. So it's somewhat business oriented, but there's different tracks too. But it's kind of been a bit information overload. I feel like it could be structured a little bit better. So like there's like technical talks, and then a bunch of other like panels and segmentations, and I honestly don't. I've been given so much information. I'm also going to check out this person. She's done a lot of really cool stuff for sensors and health tech related stuff, digital health related things. Katabi, she's an MIT person. I don't even know how to like describe what's there. It's just like it's like a big summit of all sorts of AI related hoopla and also legit stuff.
Yeah, I was gonna say.
Yeah,
like the theme is hoopla,
kind of a lot of like everything.
No, I know. They're like it's a lot of like very MIT centric or Boston centric too. I see a lot of people from that area kind of there.
I feel like it will be a little agenda.
It's just this blows up. This is a PDF of the thing you're trying to zoom in on. There you go.
Is it actually okay? It is actually updating a bit.
Yeah,
that's something. All right. So I guess in column 1, on the 6th floor, we have future of search, AI transformations, investing in AI. I'll try to make this a little bit bigger. I can't zoom in anymore. I'm sorry. Okay,
that's
zoom like this. Okay, here we go. We'll do extra zoom. This looks like a lot of business stuff, startups. A lot of talk about LLM stuff. Blockbuster interview with Lex Friedman and Stephen Wolfram. AI adoption of large companies. Next breakthroughs AI after the transformer. This is the Daniel Russ panel. What to expect in the future. Going backwards in time. Power of AI.
Yeah.
That's what I'm about. Army intelligence. An army of intelligence led by a line of trust. Let's get your buzzwords there. coping, something we probably do. Gen AI for innovation, reimagined, startups, care delivery will probably be very relevant to some stuff I'm doing elsewhere. Multimodal AI revolution, frontiers in AI research. That actually will probably be really, really interesting to look at for some things that we're doing and something that I'm interested in doing. And then column has no title, so it's people, I guess. Are these all lightning panels or something? I have no idea really. Probably a bunch of lightning talks, I'm guessing.
Yeah.
I'll look for those individual people, and then maybe more. There's technical talks here too, I guess.
Yeah.
All right, sure.
No, it's got a lot of. It's a very broad sort of different topics in AI. And,
it feels a bit like a slightly more business version of NeuroIPS condensed in one day on 6 floors, and it's going to be a big mess of everything. And I'm going to try to come out with some. I've identified a couple things. I'll get the Rust panel and the other panel, and then I guess if there's any names, if you look through that and you see names that you know, and let me say, hey Jess, check out blank. That might be the thing to do.
Yeah.
You don't have to. Just not a big deal. I don't think I'm going to send. I'm not going to write detailed notes on everything that happens there, but I'm going to network and try to find some stuff that would be good for us. Okay.
Yeah.
Imagination, action.
Looks pretty cool. Yeah.
I wish I was at the event last night. That could have led to the 11 Lab invite today, but in the future, I will speak it into existence. That I hope in the future that'll happen again. This is the conference. What am I trying to do here? Yes, this is the event in Oxford that Plotches will be at, and I mostly will be at. It's May 1st. It's just a small event, but it's really relevant to a lot of what we're doing. There's a lot of cool things. I would really like to be able to talk about this, and then also maybe if Hussein and I could just have a discussion at some point, because I know he's doing quite a bit in the gaming space and VR space, and just have a future fireside chat. That's come up a lot in these talks I've been in Boston. So I guess that term's coming around again.
What is it?
Suggest fireside chat always feels a bit antiquated and outdated to me, but it's come up a few times in Liz events here in Boston, so I guess maybe it's a Boston thing to say fireside chat. But I would say let's maybe Hussein and I could have our own fireside chat about gaming at this conference. And I know he's doing a lot in that space and excited about that space. And I don't know, maybe that'll be part of what we talk about this summer.
Yeah, you could meet in VR and have a little room with a fire.
Yes, exactly.
Makes a bit more sense, yeah.
Virtual fireside.
Yes.
There we go. Aesthetically appealing virtual fireside chat. After I forge the future, I can feel the fireside aesthetics.
Yeah.
Great. So that's kind of the lookout. I feel like there's some other stuff for this month I'm forgetting that are events. I mean, I said it earlier, but April is just everything pent up and just waiting to burst into the proverbial pollen of the air is here, and everyone else is going crazy now. And it's just I've been sick and I'm still doing this and that, so just a lot's happening. And then we have Google Summer of Code is right there.
Yeah.
And other things in the lab too. So just a lot going on.
So what is Plot Twisters doing for this conference? Are they giving a talk or poster?
I forget if we have a talk or a poster submitted, but basically we're just going to be sharing our update. A lot of it will be on sort of the, I don't want to say not exactly back end, but like how we as an organization are working to make games and interact a little bit differently too. That'll be part of it. But also we're going to talk a little bit about why we're trying to make the game the way we are. It looks like, I think we're basically going to, I don't think we're going to do a demo. Don't hold me to any of this, if anybody sees this. But I think we'll be part of a few discussions and maybe have a presentation, essentially on our experience as doing what we've been through, and how we're trying to insert into a gaming world some of the values of like self-awareness or reflection, or like the tension between we're not trying to do teaching, we're not trying to be a course in the gaming world, but we're also there's stuff baked in. So how do you make an environment? The medium is the message in a very overt way, but like how do you make an environment that's conducive to stuff while still like one of my angles that I mentioned and a few other things there is sort of, there's sort of the rub against, you have to be able to quantify and digitize things to an extent. And how do you bring awareness to that reality? Like it's still going to be, you're going to have to use numbers and evaluations and states and make some dividing lines, even if that's some of the stuff we're looking at, trying to really bring nuance to. So that's an angle that's kind of come up before. I don't know if we're going to center that necessarily this time, but that's certainly a factor. And then I think in this inclusive gaming, it's sort of how one of the things about plot twisters I would say is that we one of the premises, and this is not a trade secret or anything, but the premise of plot twisters is sort of creating another world that's related to the current world, but slightly different. Like you enter plot twisters and they're sort of referencing towards the world that we know, but there's a sort of not quite breaking the fourth wall, but sort of interplay between a world and what's normal in that world, the plot twisters Twisterland, I think it will be, and how things happen there. Like there's different ways that transportation works. There's different ways that someone is interfacing with their feelings. There's stuff we're trying to do with interpreting like sentiment analysis and informed journaling. Like when someone is writing a journal entry or conversing, interacting with the game world in text-based ways, how can that be reflective of being inclusive, of kind of trying to model different kinds of interactions, things like that. And I'm sure there's going to be a lot of questions. Oh, what are you going to do with LLMs? LLMs are doing this now. How are you going to incorporate ChatGPT and whatever? And that's something that we've had to think about a little bit. And what's I think a great question to ask at this event will be, what are you going to do with the push towards LLMs that are coming on many different fronts? And I say that in reference not only to games and stuff here, but at this event. At this event, there's a lot of focus on, okay, how do we deal with secure patient data access, but dealing with your EHRs or EMRs, your electronic health or electronic medical records, and how do you make them more conversant? How do you use text to speech, natural language processing? How do you do these things to make sure that what's said isn't lost, and ends up into the notes, or dialogue with the notes the right way? And there's certain all that stuff is sort of going to be swelling as a sort of content that is, everybody's going to want to talk about that content-wise, but the actual principles and the nuts and bolts of almost philosophically and what you're doing is going to be, I like it's going to come up here, it's going to come up there, it's going to come up tomorrow, and another one too. So I think for me, even just learning how these different groups are talking about all of those things as they're implementing technology is going to be sort of a definite education, even if it's not the main attraction. So that's probably all I can say about it right now.
That's good. Yeah.
But you can, you should go according to this great decision tree, whether or not you are or not a gamer. So, I think I'm a selective gamer now. Like there's certain games or at least I watch Let's Plays of them because I don't really have time to play video games anymore, and I don't really enjoy playing video games. If you're like grinding video games where you have to do a bunch of stuff, I'm grinding in like to write papers. I can't do that for fun on the side. Anyway, any other comments people want to share, updates about stuff before we jump into the paper? I know it's been a long time since we actually had an update, so I probably said more than we needed to, but anything people want to say before we go to the paper today?
I've been okay with the break because I've been quite busy. I've also just been kind of neglectful of the Slack. So Morgan, I know you sent me a few links. I don't even think I've opened them all yet, let alone read them. So
no worries.
I've just been occupied, but I guess I'm grateful that this isn't like a degree program where there are consequences, serious consequences for falling behind. So I'm glad that this isn't a source of stress, and I'm happy to be back.
Yes.
There's no falling behind here.
Right.
There's only falling forward. That's right. Or I don't know. But yeah, I think Morgan's official title in the lab should be like super connection coordinator or something like that.
Oh yeah.
I was gonna say man who sends too many links.
Yeah.
But it's just super interesting time in terms of the brainwaves kind of work. Literal standing wave kind of work that's happening. Earl Miller and just really interesting discussion on Sunday with just all these neurotech meetings where people who are tracking this and very happy to talk about it when you have time, Amanda.
Yeah, cool. Thank you. I would love to.
In seeing these areas, I think Platters will definitely be talking about interactive storytelling, potentially innovative gaming spaces. Maybe this one, maybe some of those. Definitely DEI stuff. In the sense and diversity in gaming narratives, because a lot of the crew putting together are very a really interesting set of backgrounds. One of them actually, I found out one of them actually has a totally different career, but someone's actually considering going into social work as a master's of social work too, which is something that Jen, whom I mentioned, is not in Plot Twisters, but is also looking to do. So we have a lot of like people who've done research and people who are doing some technical work and working on some of the algorithms and whatnot too in these spaces. And so it's honestly, a really cool group of people getting at these different points. And so I'm honestly quite curious to see the other groups there too, because I feel like between what Plutchers is doing and then finding other groups there, what they're doing and how they're doing, I think one thing we can take back from this event will be like obviously XR, etc. And maybe some of these things about like I don't know post-human gaming is really supposed to be, but the accessibility in hardware too. But I think there'll be some interesting, and there'll be a lot of interesting things. In some ways, I think this event might actually generate a lot of really maybe fewer total, but a lot of really high quality leads that will lead to things, a potential fireside chat, virtual or otherwise, with Hussein, and then also things in the lab. A lot of the stuff we're maybe considering with Google Summer of Code and other sort of virtual environment and spaces dealing with those technologies. So yeah, that should be. I'm only a few days ago I was like, geez, I don't know, and now I'm like, okay, we're going. So I'm still kind of emotionally processing that I'm going, but I'm looking forward to it quite a bit. So that should be fun. That said, I think it's time to return to interoception as modeling, allostasis as control. And I vaguely had an interaction with Eli on social media, well, like a year or two ago, and I just realized it was the same person. Yes, it is Eli. So the first author of this paper I inadvertently know through the most weirdly ways of like knowing people through social media. And then this is, Lisa from the Bears Lab, who I think a co-director with, I think she's a co-director with Karen Quigley. It's like the Inspire Interdisciplinary Attractive Ad. Yeah. People.
So they're all from the same research group?
Yeah, it is Karen. Okay, yeah. So they're all from this group, yeah. So last we left off, last time, previously, I think we basically were getting to the positive theory of what they were saying, and I don't quite remember where we were. Like we had this sort of, to look at this outline, right? We had kind of this bit about interoception, modeling the body, estimating sufficiency, regulating resources, modeling variable ranges, viable ranges, and making control theory. And to return to let's look at the abstract again, I guess. Anticipating the needs, intending to meet them before they arise, the allostasis. It requires a model of the changing central conditions of the body, a process called interoception. In this paper, we examine how interoception may provide performance feedback for allostasis. We suggest studying allostasis in terms of control theory, reviewing the control theory's applications to related issues in physiology, motor control, and decision making. We synthesize these by relating them to important properties of allostatic regulation as a control problem. We then sketch novel formalism for how the brain might perform allostatic control of the viscera by analogy to skeletal motor control, including mathematical view on how interoception acts as performance feedback for allostasis, and we suggest a way of testing these hypotheses. So we were, I think, basically getting to part 4. I think we spent some time here, but I think we can either go to like 4 or 5, and I'm just trying to see any key points here. I think I organized this somewhere else, but I can't quite see what it is. So I just have these kind of scrap notes right now. So apologies for that.
I see on the Notion page, there's a couple steps for this, and one of them you have labeled Amanda's, but it's not. I didn't make it.
It was. Yeah, I thought you did.
AI generated though. Like it looks like someone just is like summarize paper to.
Yeah, I think these were actually like Chat GTP summarization, something that I flipped through in here a long time ago. I don't know if how useful they're really going to be. So I don't know. The other one was I think blank, but just had some the actual data. Okay. So I mean, if you see anything on this page that you want to point out, the one that you saw that was incorrectly attributed to you, Amanda, you can let us know or mention it. But I don't.
No, it didn't seem super helpful because
it was kind of just
I don't know. It was just like vague. Like it used the same words as the paper without like really explaining
Yeah.
them.
generative AI garbage. So, it's the not garbage in, but garbage out. So it's the worst of all possible worlds when that's the case. Don't tell Candide. Yeah, okay. APIC, I think, is their theory: computational unification, decision making, and control for these concepts. Yeah, unlike most work in predictive programming, APIC is designed from first principles to solve a combined problem, both decision making and motor control, rather than to address perceptual or cognitive problems. So I guess they have a decision making approach. Unlike other predictive processing models, APIC is the objective, or in APIC, the objective is optimized, what? APIC, unlike other predictive processing models, in APIC, the objective is optimized, there we go, okay, by making capacity curve precisions small, implying greater resilience to challenge, rather than large, implying greater resilience to reduce resilience to challenge. The most elementary of the APIC model's first principles are the body. It is considered as a set of coordinate systems. Okay, the study of these decision-making in neuroscience begins with assumptions from Zillow and Clark or Kizek, and an emerging body of evidence suggesting that the brain controls the body by keeping many possible actions in the running until sensory feedback forces an irreversible decision. And their model works this way by default. Yeah.
Do you can you go in the paper to this APIC, or where they talk about the capacity curve? I don't think you have it in the notes, but maybe we can find.
Looks like we have a box. I don't know if this is going to be
probably one of these papers where the figures on at the bottom, but yeah, I don't know. Oh, there it is. Capacity curve, figure 1. Yeah, there we go.
Okay.
Okay, so that's the capacity curve. So when they say that the capacity curve is, the precision is small, I don't know what that means. Let's see. So capacity curve for baroreceptor afferent firing, taken as a pedagogical example from Hough, as the curve flattens in either direction. So as it gets like towards the bottom and top of the curve, the baroflex can no longer respond proportionally to changes in blood pressure. The tick markers show the threshold value, the saturation value. And so when they say the curve is small, what does that mean? I mean, is it like the bottom and top of the curve, or the middle of the curve? I guess it would mean that the baroreflex is like, able to respond or not able to respond. That's my interpretation. And so, like the decision, you'd have sensory input coming in, and it would tell it, okay, you need to change. You can either change or you can't change. If you're saturated, you can't change. If you're not saturated, then the change, it's free to change. So yeah, I don't know exactly if that's what they mean, but it's kind of interesting.
I wonder if they're meaning like at all the slope of it, or just like the range. It's a bit unclear to me.
Well, yeah, but the physiological aspect of it is where you have, like for mean arterial pressure, if it's really low.
Okay, here's maybe the next like immediate thing.
So yeah, the operating point is in the middle, 100%. And then if you're going in either side of it, you're able to respond. But then if you go too far out, you move away from that trend line, so it saturates. So it's like if I'm, have really low arterial pressure, can I respond by having a baroflex activation? And so if I'm on that orange line, then I can. But if I'm not on that orange line, I can't. So if it's like if you're if you're able to, if your capacity is really low, or where you're low or high on that curve, then you can't respond adaptively.
Mm-hmm. And I think this makes sense. Or like trying to sort of identify basically allostatic points or ranges.
Right.
But let's see, shows the respective operating points of the curves and the space between the two markers denotes potential settling range for blood glucose content. Okay. There's another one.
So different physiological variables respond differently to other variables in a way that it's patterned, and from the combination of all those patterns, we have this model, this interoceptive model. Is that the big idea? Like you combine all of these various curves, and that's like the input, and from all of that, we have like the brain somehow has an idea of the body's state.
Well, this is the control system. So if you have reference signals, which are like things that are inputs. You have state estimators, which kind of estimate the state. So they're not all equal, and they're arranged like a control system. So you have prediction error, of course, which means that when somatosensory exteroceptive state estimators, actually that's a state estimator of skeletal motor decision controller. So the decision controller goes to the exteroceptive state estimator. That state estimator then goes back and sort of constrains the decision controller. You have, let's see, I'll pick one, allostatic capacity estimator. And then that feeds feeds a prediction to the interoceptive state estimator. And then that feeds back to the alloceptive capacity estimator, or prediction error. So the idea would be the capacity estimator is trying to minimize the prediction. And so, if you have a predictor, the idea is to minimize the sort of the range of output so that it's predictive and not just all over the place. And so some of these variables they serve as sources of prediction error. They can tell you if you're too high or too low, and then the plant, or the main variable, then changes its behavior accordingly. So there are all these different control theory relationships. It's not causal necessarily. It's just that there are these different functions that are basically happening from these different things that they're looking at. So it's not. Don't take this as a causal map or all things affecting all things. Yeah.
Okay. I think this version of the document has things a little more in the order. So it might be easier to see in context here. I don't know. I'll keep this on the side, I guess. Let's go here a little bit. It's a little bit jumbled up here. Okay. Yeah, this is a good point. We should probably do something we talked about before, was this comparison of control theory, model-based control versus cybernetic systems. That kind of feels like in our I don't know. We have this sort of running list of potential things to do, like in this group and the other group, and I should really collect them all somewhere as like what was the one in the last meeting for the reading group theory? It was something about like, I don't know. I don't even know if we put it in here. Like Randall Beer, embodied stuff. Okay.
I think these are from the cybernetics meeting, but yeah.
Yeah. That's what I meant. But yeah. Oh, I see Amanda put something here if you want to talk about that.
I'm just putting screenshots of the bits that I had highlighted that are, I believe, all in the conclusion that are relevant to maybe this comparison of different piecing apart like what control theory is here, what a model is. I just don't want to lose these highlighted bits.
Yeah, no, please put things in here as much as you want. It looks like we were getting towards what is the author setting as a relationship of reinforcement to the new model, giving us our reinforcement learning in a model, I guess is the question we have. And we mentioned Sterling over here, prediction errors, organism modes. I think if you want to just go through these things in the conclusion, we could basically make our way there. I'll start trying to find a good way to show that, whether in this document or the other one. But these are from 5 point much higher. Yeah, okay. Oh, that's kind of crappy. I'm gonna look at this one.
I just thought that this captured the big picture well.
Okay.
I thought it was interesting that there are that they think that this model allows for like certain empirical predictions and hypotheses and then experiments. Although I don't remember ever finding like a specific example.
Do you want to go over this one? Or? The body and the brain through the lens of control theory. So they've introduced these control theory methods. Control theory provides a way to conceptualize how physiological systems can function reliably as a whole, despite being built from unreliable parts. I wonder what Levin would say about that. Maybe they just have different agencies than the reliability we want.
Yep.
But I think there's also like, what's it called? Redundancy. You were saying?
I just said that that's a good point about Levin's view possibly diverging from this.
Yeah.
I don't know. I guess maybe I'm not appreciating all the details, but and I also I haven't read this paper closely in a few weeks now, but it seems like what's most important is like the idea that, I don't know if we want to call it emergence, but like this is a way that the whole is bigger than the sum of its parts. Like if the parts are all, if there's so much room for error, then like with the way they all fit together somehow allows this sophisticated organism and like efficiency and really like maybe close to optimal functioning. So I guess I'll pause there for now.
Yeah. Yeah, I mean, and it's not like perfect function here. We're talking about like, how do you get some sort of like regulation? I mean, that's been basically in the whole enterprise of cybernetics. But like, when you have a system where you have two parts and they have to sort of, function in a unit, then there has to be some relationship between them. So there might be some imperative for prediction where you have some signal that's strong enough to actually provide a useful prediction. You can think about that as like a system being put together in evolution or maybe development too. How do you, if you have parts that need to come together for a system, how do those things become associated functionally? How do they maintain that function under a wide range of conditions? And sometimes they don't. Like, where you get saturation in the curve, or where you get like a situation where, something malfunctions And sometimes when parts are, worn out, sometimes when, in biology you have sometimes a lot of different copies of something, or, places where one can pick up the slack for another thing and serve the same function. And that's because, you have this robustness in the system where if that control doesn't work, or if something dies or wears out, then the system doesn't collapse, it continues to function. So without getting into too much more detail, you have systems that sort of have this redundancy, but you also have this imperative for prediction and control. And so, you get these systems that have all these parts with, different types of relationships. So you get these systems that do things that are body wide, and they can actually be quite complex in their structure and actually quite sophisticated in their control.
There are also many opportunities for something to go wrong.
Oh yeah.
So I
guess a related thing for me is like, is this and there I believe the Eli and co are citing someone else here, but okay, like yeah, this I believe APIC is their model, right? Like that is what they're proposing, and saying the novelty or the importance of that is that the body can only do one thing as a coordinated action, but the brain can do these many things at once. And then they're building from Kaisak and Zulo, and have the body. There's sort of all these possibilities up, but then there's this. It looks like they're taking their model to say, okay, because of path-integral control and whatnot, there's these possibilities of decisions that are eventually enforced into one of the unified, like coordinated action at a whole body, whole person level. But I think, okay, yeah. So they are building off of this stuff to say this thing about in the learning part.
Yeah. Well, I mean, I guess a good way to think about that is like a circuit where you have multiple pathways. It could be something in the cortex where you have different network topologies, and they might not all be the same in every person or every time you process information, but there are a lot of alternative pathways you can use. So if you're like, if you have some brain damage, or if there's a path that's faster under certain conditions, the brain can can enforce, like provide a prediction that forces the physiology to take that path. And so that's it's basically where you have it's like taking the redundancy, and it's context dependent, where it gets collapsed to a single pathway. So it's like basically telling it where to go under what conditions. Because the sensory feedback, I think, is critical here, because if you're in an environment, like if you're swimming versus if you're walking, those things have different types of feedback. So you can't do the same types of things. Like if you've ever tried to walk through water, if you're in the pool and you walk forward, it's a different type of gait or different type of dynamics than if you walk just kind of on a floor, And so you have these different, you have this different sensory feedback going on. So your body compensates for that. That's just a very simple example, but you see those compensations all the time. Sometimes, people do these postural sway experiments where you put someone on a platform and people naturally sway back and forth. And it's just because that their nervous system generates a lot of noise, and that noise keeps you stable because it keeps you going in one direction then another, and then your muscles correct for that, so you end up standing upright. You're kind of like a very slowly listing weeble wobble, but your muscles keep you upright. But when your muscles fail, sometimes people have disorders in their muscles. They can't keep their balance, and it's because they can't keep themselves from listing off to one side or another. So, there's this control signal that you're getting, but it's being reinforced by the paths available to it. So sometimes the feedback maybe can overshoot, and you end up falling on the ground. There's without getting into too much more detail, there's an interesting set of interactions there, but yeah.
I think there's something interesting about this space, which I believe is where this is quoted from. I know it's kind of awkward bouncing around here. But to that end, what they in here they're saying this the novelty is sort of about combination of the neuroanatomy and the feedback control. Yes. Okay. Whereby the same mechanism can control same mechanism can both stabilize movements, keeping close to the original action concept, and maximize decision values. So the unification of inference with feedback control handles uncertainty about the consequence of movements, uncertainty about the state of the body in the world, and uncertainty about the reference or objective of action, RL, in a single framework. And I guess to kind of go outside the scope of this paper, I think what's interesting about this is that in some of the I don't know what to say. Some of the theories I'm working on building out slowly over time, something like that. There's something about the sense of agency and affordance, and maybe some metacognitive stuff. I don't know. Confidence in that space of being able to manage the noise and the variation of the noise, and also the possibility space of action. And under if you're injured physically, oh, I can't, my space of possibility is different. And there's similar things too for lack of better words, and this word is used a bit too much, but when traumatic experiences happen and there's a mental inhibition of grasping or handling certain things, or emotional inhibition, there's similar the comfortability of managing the space of instability, of dealing with noise, of whatever seems artificially constrained. And there's just like when you're you can only walk so much when you have a broken leg, you have to kind of have a narrower range of options. There's a similar version of that for other I guess we can say mental spaces, but I don't really like those words right now. But I think there's something interesting about that I'd like to apply some other situations too.
So
cognitive aperture. Go ahead, sorry.
This APIC model, do we have a figure where they lay it out? Is it like a mathematical model?
I don't remember actually seeing a good one, but you'd think that there is somewhere. This one isn't.
Okay. Allostatic Path-Integral Control.
Yeah.
So it's probably let's look at the figures actually. Maybe they have them in there.
Maybe let me look at this other. I'm going to pull this other document because this figures make a little bit. This is page 21-ish. Oh, this is not working out. Okay.
It's a block model.
I don't know if we can just scroll to the bottom here. Nope.
There's a lot of math. Yeah. I don't know. Maybe it's a mathematical model. There's some equations here that are probably maybe useful. See, maybe we're getting here. This is decision making. Maybe go down to the next page. Right here. This is summary, formal model. Okay, this is the subsection. This is it. If we go down to maybe down, maybe not. I don't know. Oh, there it is. Invite by APIC. So we're keeping. Yeah.
A generative model, figure 10? Is that what we should look at?
That could be, figure 10. I'm just trying to get a sense of it. I think it'd be worth seeing the parts laid out, but I also don't want to spend 20 minutes finding it.
Yeah. Okay. Let me try searching this other one.
All right.
If not, then what would it be? It's not working at all there.
All right.
I don't know if this is the figure.
Well, I think the figures are at the bottom of it. There it is, right there.
There we go. Okay.
All right.
Well, this is the passage of time one. So I guess, general model capturing multiple time scales and reference distributions at each level. Okay.
Yeah. Can you zoom out a little bit? Like maybe, I don't know, where is it? There we go. Yeah. There we go. All right. So that's the hierarchical generative model. And so what's going on here? Let's see. So we have increasing time scale, and I guess it's like time scales are like, maybe milliseconds to seconds to minutes, reference distributions. So this is hierarchical. It's kind of going up in time. And then there's the passage of time. So you have, over the time that it takes you to do some behavior, some action, or, experience interoception. So we have these different levels. Without addressing empirical questions about neural hierarchies, here we employ a model with 4 levels to match figure 6, which is not like, we don't need to go there. Nodes denote unobserved latent state. Okay, so these are latent states. So these aren't like actual states that we can identify. It's just kind of a latent state. You could use like a hidden Markov model to find them, or some statistical model like a linear model to find them, or structural equation modeling, I guess. And so you have these latent states, and each represents parameters of a reference distribution for. So phi and s are related. So you see the S is kind of coming down in terms of time scale, and then phi is actually the thing that's getting something from S. So if you have like, let's see, so the S is a reference distribution, and then your phi is representing parameters of a reference distribution. So it's like you're getting these distributions from the environment, from the interoceptive world, and then it's extracting out these parameters that are then used as the means for prediction, I guess. And then of course you go down like in time scales, so a larger time scale, you're collecting data, it's going down to the next time scale, and so forth. Where I don't know I guess this is increasing time scale going up. So these are going down. So I guess maybe longer time scales are influencing smaller time scales. I'm not really sure. I mean, that kind of makes sense because if you think about your own, when you do things in the world, you learn from larger timescales. So like if I'm doing something in the moment and I want to have a prediction about what if I want to how do I move my fingers or move my toes, those are things that have been learned over longer periods of time. And those are the more likely things maybe not to get you injured, or that you have. And sometimes, it's hard to sometimes, you maybe your toes injured and you don't have, you forget, and you're just kind of operating on this sort of procedural learning that you've acquired on a longer time scale, and you can, feel it in the toe. So, so longer time scales are informing shorter time scales. OT represents observed sensory outcomes. So you observe, like you get these sensory inputs from S. P is the extracting parameters. Then O is like the observations of the sensory outcomes, I guess. And AT represents the closed loop control actions generated by motor reflexes, which is down at the bottom there. Yeah. So from all these time scales, you're distilling out sensory outcomes, observed sensory outcomes, and closed loop control actions generated by motor reflexes. So your motor system is doing this at a pretty quick time scale. You don't process, sometimes some of the motor reflexes are processed peripherally. So, you have processing that goes on in your spinal cord, for example. So when you walk, you're not you're monitoring your walking, but your peripheral nervous system is taking care of a lot of that prediction and processing. So and they don't talk about different neural hierarchies here. So that's not part of the model. So whatever your central nervous system is doing isn't that relevant here. But it's just basically that you have these sensory inputs, you have these reflex arcs, you have other types of reflexive behavior, and those happen very quick. And you learn from maybe longer time scales, and you distill it down to the short time scale. And then there are these two things that you're getting. You're getting a feedback signal, and you're getting an observed set of things, which is a filter. It's been filtered through all the things that you experienced. So that's basically what they're getting at.
Okay.
Yeah.
I have a question. I don't know if we can answer again what we know so far, but basically when they say parameters to a reference distribution, is this, and if we don't know, I don't know, but just from how they're saying it, is reference distribution specifically I guess what is the reference distribution? Let's start with that.
I guess it could be. Yeah, I guess it could. Well, in mathematical modeling, you'd use a reference distribution. So, like, you get a bunch of inputs, and they don't follow a neat distribution, right? I mean, you get like inputs that are, you sample a certain amount of the world. Let's suppose that, like, there's a phenomenon in the world that's basically Gaussian, right? So it's like they're tails, but there's a mean, there's a central tendency. But you don't experience that entire distribution all at once or ever or whatever. You'd get parts of it. So, you might say that like you have a representation in your nervous system of a Gaussian distribution, which is controversial to say that because, who knows if the brain has a representation that's Gaussian or what. But you can, in modeling, you can certainly use a reference distribution like a Gaussian, and you can fit the data to a Gaussian or fit it to whatever parameter that you would like, providing that it's a good fit, and there are statistical ways to do that. And so when they say parameters too, that means that if I say like there's this thing that there's sensory input to the system, and it maybe resembles a Gaussian, or I know I can model it as a Gaussian because it looks like from this first pass, I just kind of plot out the points and I say, okay, that's a Gaussian. I'm going to use that to model my system. So I can use that and I fit everything to a Gaussian. And then each parameter or each distribution that you use have certain parameters to it or certain moments. So if I take my distribution, how do I represent that to the nervous system, or how do I represent that in my model? I can't just say I have a Gaussian. I have to describe it. So you use moments like mean, variance, standard deviation. You use different, there are other parameters you can use. But those are the parameters. So if I want to pass the mean of the distribution, I say let's take all sensory events, fit them to a distribution, take the mean of that distribution, pass it on to the next thing, and that summarizes the distribution. So I know where I could take the mean and the standard deviation and use that as the two parameters I pass on. That describes that distribution enough so that I know that if there's variation between inputs, that it's a Gaussian, it has a Gaussian tendency, but there's maybe some change in the mean or in the standard deviation. Standard deviation being like the variance, and then the mean being like kind of the average of what's going on. And it's not a complete description, but it gives me enough to say that if there's like a change in the sensory world, if the mean is much higher in the next set of observations, then I need a feedback signal to correct that error. Or if I'm predicting a much higher rate of increase than actually is observed, then I need a feedback signal to say, let's tamp down the response because what I'm predicting is wildly out of step with what's there in the real world. So there's this interaction between the model, and sometimes people say that we can do this in our brains, like the Bayesian brain people. They say we have Bayesian processing, whatever. Sometimes it's just with the model, but in any case, there's some summary of the signal that's coming in at some point in time. There's some prediction of what maybe the next step is, and then there's some feedback that says, am I right or not? Is my prediction right? And so that's basically how this is done. Now, this is a pretty busy diagram, but all it really means is that at very long time scales, I can summarize all that information in a set of parameters. Smaller time scales take that information and use it as a prediction mechanism. And sometimes it's correct, and sometimes it needs a correction from a feedback mechanism. And so you have to do it that way. And it usually works because, you get this kind of closed loop feedback where you say, here's my distribution of what's going on. Here's the next point. Does this point and the next point match, or are they close? And if they're not close, then we need to have a negative feedback signal. And then that will correct it. And then I can keep doing that. And eventually I'll optimize control because, eventually you'll know kind of what things, you'll know from the behavior whether you're doing well or not in the global sense.
So I don't, that was very good, thank you. In addition to that, is it fair to say, I may be interpreting this figure too much in a certain way. Like, is it fair to say like this box essentially represents the agent and the moment that it's in, whereas these are essentially longer predictions at longer time scales, like operating at that time scale where this time scale at a higher level, longer term is.
Yeah.
And like this is being informed because of the longest. This is informed by the second. This is informed by the parameters to a reference distribution are influencing this shorter term, lower time scale prediction all the way down to that. I think essentially predictions, these S unobserved states.
Yeah.
Is that like a prediction state, or like we're assuming if this holds at this time scale in the future, it'll be here?
Yeah, so you're trying to predict what state you're going to be in, or what state. The latent states just means that you're modeling that you're, in the nervous system, of course, these are just states that are sort of predicted. So like, this is a stable state, this is a stable state. You can make these predictions and of course be wrong or be right. This is, I don't really know, like, it's kind of hard to define what a state is in a physiological system. I guess that's a stable operating place, but we don't necessarily know these in advance. Now, your physiological system, of course, you've been living with it all your life, so your physiological system knows I guess, kind of, and this is the whole logic of homeostasis and allostasis, that it knows, the canon book was named Wisdom of the Body. So the system knows what the stable states are. It knows kind of where the set points are and how to return to the set point. So those are all kind of assumed, and we don't want to say that this is any one particular state. It's just kind of like the stable ones. And so here, you can actually predict out in time. So you can predict the next state pretty easily, but then going out like 5 or 10 or 15 minutes, you have to make a set of predictions, or your system has to make a set of predictions that is increasingly, you need to have, it's a different operation to make a prediction as to how to regulate your temperature 5 minutes from now as to regulate your temperature in a day, so there's that aspect of it. So really these are just, different time scales, and it requires maybe different observations. So you have these different observations at different time scales, and they kind of contribute to the next time scale and so forth. So it's not an easy problem. We talk about this very freely, but in the brain, of course, the body does this well. We generally can regulate our body temperature or regulate our walking or whatever. And of course, if we're injured or we're sick, we can't. But this is something that is, building computational model of it is actually pretty hard, but the body is doing it. So they're just hedging their bets there. They're saying that we can't model the neuroanatomy explicitly because we don't actually know what the actual parts are.
Right, and I'm assuming a lot of this would be going on in the body, not in the brain in particular.
Yeah, so
computing
cellular level, one like this figure, the full version would involve, it seems, everything from single cells in the body to well, I guess that's one of my questions is like what would the highest level be? How do you connect this to subjective experience if you can?
Well, there's a lot going on in the peripheral nervous system, depending for interoception, definitely. And you have sensory, they call the gut the mini brain, and it's because it does things that the brain does as neurons, and it has processing relays and things like that. So there's some of that happening there. Some of it happens in the central nervous system, not because the central nervous system is the only thing that can control it, but because you're getting inputs from emotional state and inputs to emotional state from other circuits. So it involves a lot of things, and there probably is input from cellular states or things in the microenvironments of the body that come into this as well. So they say the latent states come from this latent space. It's just a way of modeling it to say these are all the possible options that we have, and these are the states that kind of emerge from that. But in the body, of course, there's, and again, you could, depending on the system, you could find specific mechanisms. There may be multiple mechanisms. We're not going to worry about that right now, though. We're just trying to show the architecture here of the mathematical architecture.
Yeah. I think this has been a very stochastic cognitive control general model. Yeah, this has been, I'm glad we got to this, because I think this is sort of, it'd be really interesting, as we kind of alluded to before, kind of meshes with some of, I don't really feel like I'm even qualified enough to say what Levin would say at certain parts of this, but his sort of ideas about his take on the top-down control influences and how it meshes with this, and what I don't know. There's not really enough for me to really intelligent reference here. But,
I guess the lesson maybe that Levin would have would be like, cells might, like cell populations that aren't neurons might contribute to this as well. And you have, really kind of thinking about how the origins of this kind of control, maybe like development or evolution. How do you get like something that can regulate? So you have to have some starting point, and you have systems in like sea slugs or things that are very simple circuits where you have control of like the gill slit, and that's a very famous set of experiments where they can control the gill slit using pharmacological agents, or look at the adaptation there. And so then you can move up to larger systems where you have more parts, a bigger brain, and so forth. And so these are all kind of there's a lot of stuff you can do with these kind of models that are really interesting, and looking at the origins. And I think with Levin's competencies, you'd say, well, these cells are becoming more competent as they, become part of these larger systems, because they have more information from the environment, from the actual body. There are more states that you deal with. Imagining emotional state, there are a lot of emotional states, maybe more than are expressed on the outside, right? Like you have things in processing of emotional state that involve a lot of different intermediate states. So yeah, there's I don't know, this is something we'll probably return to, I think, in future meetings.
Well, speaking of future meetings, let's have a moment to discuss that, because this has been a really good. I'm glad we kind of got to this and spent time breaking down the things. It's something I want to do more of, and I think I haven't done the best of, is getting to like the heart of the paper and like actually having more fun and insightful discussion of that. So I'm, acknowledging that something we can try to do more of specifically. That said, we are at the top of the hour almost. We have a little bit of time to talk about what's ahead. There's a number of things that have come up on the table, a bunch of Levin stuff. There's Tom Froze's eruption theory, which has been finally released to the public and is a big deal. And Froze is kind of close to what's his face, Fuchs, and is in the same fridge, I don't know, arena of like Varela type stuff somewhat. And I don't really know anything about the eruption theory yet at all. So that's on the table. Let me look at the Slack here, but any sort of like candidates or things people are particularly excited to look at. I know I'm going to go through the Slack. I know there's been a bunch of stuff in there. This book I downloaded, Vincent Raha, Ecological Psychology, is out. That's sort of a relevant.
I think my vote would be eruption theory.
Okay.
It seems really like novel, but also relevant to things we've been discussing. The Raha book I would also read. It seems like it's more, it's like less argumentative and more introductory. So maybe less, I don't know, less provocative, but I'm not sure. I haven't looked super closely.
Yeah, let's maybe just target that. That's sort of my. There was something else I'm trying to find in here that I cannot see, but I think the lean can be towards that. I don't think that's what Morgan meant to share. Yeah, let us lean towards that. Oh, okay. There's a bunch of other stuff in here that oh yeah, in the comparative cognition lab. Okay, let's focus on that for now. Let's just say let's do that, and let's do something else that comes up. That can be our current lean. I mean, this looks like even just this looks interesting. Whoop, where did it go? we lost Tom. Okay, Major Tom's. This wasn't even the most recent thing he's done, but I mean, he released it, and there's I think maybe a homework if you want is like, okay, what's the best thing that Tom has put out that we can see about his interesting. What's a good thing to look at as a first pass on this eruption theory? Because I'm not entirely sure yet. I've seen a few things, but maybe we can find something about that and be back here next week. So I think that's kind of the note I'm going to leave on. Anything else people want to say or suggest for today, or ready to let it be for now?
Follow up on Slack.
Yeah. Oh yeah. I will. I'll follow up with you about the other stuff too. But yeah, thanks everybody, and I will see you next time.
Thank
Take
you.
care.
Take
Talk
care.
to you soon.
Bye.
Bye.